It is with a tear in my eye that I make this last video of the year 2015, and it's going to be for your help sheet that you should have just gotten. It's green, I hope it's green, and we're going to be filling in the slope formula and rate of change, so the last couple of topics that we've been talking about. So hopefully everybody can remember the slope formula. It is slope m is equal to y2 minus y1 divided by x2 minus x1, where the points, the coordinates x1, y1, and x2, y2 are representing 2 points that lie on a line. So there's a lot of different ways to think about slope. We have talked about, obviously, the slope formula. A lot of you remembered rise over run, the change in y divided by the change in x, which is exactly what the slope formula is saying. And if I forgot any, make sure you fill them in. So let's look at finding the slope given a graph, given a table, and then down here there's a couple of points. You just can't see them right now. So looking at this line, the first thing I think of doing is rise over run to find the slope. And I start at a point, and I like to start at the lower point and go, a rise to me means to go up. So that's rising in the positive direction. But my run in this instance is going toward the negatives, going toward negative infinity. So in this case, my rise divided by run is positive 2 divided by negative 1, or a slope of negative 2. Now, what's interesting about this is we could have used any 2 points, and we could have done a rise of 2 and a run of negative 1. And at the same time, we could have started at a higher point, and we could have dropped 2. So our rise could have been in the negative direction, but then our run would have been in the positive direction. So either way, you're going to get the same slope. The slope of this line is negative 2. Now another option you could have done is you could have chosen 2 points. Let's say I pick that one right there. That's at 1, negative 1. And how about that one right there, which is at 0, 1. And I could have just done the slope formula there. I'm going to call this y1 and that y2. So I could have started with y2 minus a negative 1. And then I would go with my x2, which is 0, minus x1. And 2 negatives make a positive, so that would be a positive 2, but 0 minus 1. And lo and behold, I would have gotten the same answer. So there's just so many different ways to think about slope. Now, the next example deals with a table. And one strategy you could do is you could pick 2 points. Doesn't matter which 2 points you pick. I don't know why I chose those. I just did. And you could do y2 minus y1 divided by x2 minus x1. So you could use the slope formula. Negative 2 minus 1 divided by 4 minus 16. And I get negative 3 divided by negative 12. And both of those numbers divide by negative 3, so I would get a slope of 1/4. Now, this is a table is a nice way to use this change of y divided by change in x. If you have the input values and the output values all in some nice order, you can see the x values are increasing by 4 in each step from each point to the next. And if you look over here, we're actually increasing the y values by 1 every step of the way. So that's another way to look at that. The change in the y values divided by the change in the x values. Now this is the tricky part. Even I get tricked sometimes. This is the change in the x, and these numbers are the change in the y. So the y values are increasing by 1 while the x values are increasing by 4. And again, we get the slope is 1/4. And then the last example for slope, using slope formula, is you are given 2 points. So I'm going to call, since I see this point, I'm going to call this x1 and y1. I'm going to call these points x2 and y2. Obviously, you could do it any way you want. So I'm going to start with -1 minus 7, and that means that my x2 is a 1 minus a -3. Please use a calculator if you have struggles with negative signs. And I just got -8 divided by 4, which is a slope of -2. -2 divided by 1 is perfectly fine. I usually do simplify it. Now, a little trick that I do sometimes when I do have ordered pairs is I like to line them up right up on top of each other. So my y values are lined up and my x values are lined up. And so if you had seen the slope formulas this way, 7 minus a -1 divided by -3 minus 1, you would have gotten 8 divided by -4, and alas, we're going to get the same slope. So it really doesn't matter. I kind of like lining up the x and y coordinates. I find that pretty helpful. All right, last page. Oh my goodness, this is it. Last thing I'm going to help you with that's new. Obviously, we're going to be reviewing for the final. But a rate of change is just another name for a slope. But when you put that word rate in there, what that means is that it's like you're doing miles per 1 hour, or how much money you make per 1 hour. So a rate is going to be a fraction that's divided by 1. And I don't think we saw it on the front page, but we might see it here. So as I look at this, we have a helium balloon that apparently has escaped, and this is its flight. So on the x-axis is time, and on the y-axis is the height in feet. So it says determine the rate of change in this graph. Well, I see a point at the origin, so that seems like a really easy point for me to use. And then I see another point that after 6 seconds, the height of the balloon is 6,000 feet. So this to me is a kind of a no-brainer for a rate of change or a slope. So we have 6,000, that's my y2, minus 0, divided by 6 minus 0. And I have 6,000 divided by 6. Now before I do anything to that, before I reduce it, I want you to think about what is in the y-axis and what is in the x-axis. What's changing in the y-axis is height, and what's changing on the x-axis is time in minutes. So really what this slope is telling me is that every 6 minutes, this helium balloon that's escaped is rising 6,000 feet. So obviously if I reduce that, that is going to be 1,000 feet for every 1 minute in time. So this is what I would call a slope, but when I just reduced it and changed it, this is saying that it's going to rise 1,000 feet per minute. And that's really the difference between slope and rate of change, is that you need to get those units on there. And then obviously we're going to use an equation like this to interpret things. So what does this slope rate of change mean? Well, it means the helium balloon rises 1,000, don't tell me that looks like an N, I know it does, rises 1,000 feet every 1 minute. When will the balloon be 5,000 feet? Well, you can tell that one just by looking at the graph. That's going to be after 5 minutes. And how could you write an equation in slope-intercept form? Oops, sorry, you guys couldn't see that, huh? I'm struggling. Write an equation in y equals mx plus b form that could represent this situation. Well, remember the b stands for the starting point, and the m stands for the slope or rate of change. So I'm going to use the letter h, right? That's what's on my output, that's my y-axis. The height depends on time. Sorry, you can't see what I'm pointing at. So height starts out at 0 feet and then increases 1,000 feet per minute. Now I'm not using m, it's pretty standard to use t for time. And obviously adding 0 to anything, we don't really need it, so that would be our equation. And we could do some figuring, like if I wanted to figure out after how many seconds will the height be 2,626 feet, right? I can just plug that in for h and solve for time. So I divide by 1,000. And we'll get to that next year. Woohoo, next year, 2016, baby, 2016. Okay, that's all I have for now. Good luck on the test tomorrow. I'm sorry, it's Quizzarini, and I will see you later. Okay, bye.